Let us now learn trends in the modern periodic table. First of all, we'll learn about valency. We all know what is valence electron, right? What it is? The electron present in outermost orbit of an atom is called a valence electron. We also have studied valency in standard 9. What it is? Valency is the combining capacity of an atom. What is the meaning of combining capacity? How one atom will combine to another atom. That capacity is known as combining capacity. How can we decide the combining capacity of an atom? It is based on valence electron. Whether the valence electrons are donated or the valence electrons can be gained. By giving and taking the valence electrons, this combining capacity is decided. If I tell you for sodium, how many electrons are present in outermost orbit of sodium? 1. Which means that one valence electron is responsible for forming compounds with other atom. So that is valence electron, and the valency of sodium is 1. If I talk about magnesium, 2 electrons are valence electrons, and these 2 electrons are responsible for making bonds with other atom. So valency of magnesium is 2. Now, if we take example of sulfur, here 6 electrons are valence electrons. What is the valency of sulfur? You will be thinking it is 6, right? How many valence electrons are there? That means that much is the valency. No, it is not. Students, please keep this in mind. Valence electrons and valency both are different. Here, 6 is the number of valence electrons. That is true. 6 valence electrons are there. But valency of sulfur is not 6. Why? Because while forming compounds with another atom, what will be easy for sulfur? To give 6 electrons or to take 2 electrons to get octet configuration? I'm sure that you are thinking it is easy to take 2 electrons to fill octet configuration. Okay, so valency for sulfur is 2. Okay, because it will gain 2 electrons. Okay, which is the easier, 6 number or 2 number? To give away 6 or to take 2? To take 2 electrons. Okay, so please keep this difference in mind. Here when we studied magnesium, valence electrons were 2, and to fill octet configuration, either magnesium has to lose 2 electrons or to gain 6 electrons to fill octet. Okay, so which is easy, to give away 2 electrons or to take 6 electrons? To give away 2 electrons. When we studied for sodium, 1 electron is valence electron. So to get octet, either sodium has to give 1 electron or to take 7 electrons. So which is the easier? It is easy to give away 1 electron. That is why combining capacity, valency of sodium is 1. Please keep these differences in your mind. So, the valency of an atom is determined by the number of valence electrons present in the outermost shell of its atom, as I have explained you. If we talk about valency of elements in periodic table, then valence electron increases from 1 to 8, which means number of valence electrons can be 1, 2, 3 till 8. Okay. Now, valency increases from period 1 to 4. As we move from left to right in periods, the valency increases. Now let us talk about atomic radius. What is the meaning of atomic radius? Here we are learning atomic size, and atomic size refers to the radius of an atom. What is the radius of an atom? Here in the picture you can clearly see atomic radius of hydrogen is shown. How? So two identical nuclei are taken, and if these nuclei are placed by touching together, if they are placed together so that they touch each other, and the distance between the nuclei of the atoms, okay, it is shown with a straight line. So half of the distance between these nuclei is known as atomic radius. In simple way, if we want to remember, you can think of a circle, and the radius of a circle we consider here, that is from distance from center to any point on the surface. Okay, but here when we talk about nucleus of an atom, so how can you define atomic radius? Like this, if two nuclei are placed together, half of the distance between the nuclei is known as atomic radius. So when we talk about atomic size, what do we talk? We talk about atomic radius, the radius of an atom. Okay, simple. And the atomic size may be visualized as the distance between the center of two nucleus and the outermost shell of an isolated atom, as I already said. Here we have taken example of hydrogen. So the atomic radius of hydrogen is 37 picometer. The unit for defining atomic radius is picometer, pm, picometer. And how do we define this unit? 1 picometer is equal to 10 raised to minus 12 meter. Please remember this conversion. 1 picometer is equal to 10 raised to minus 12 meter. How this atomic radius vary in groups and periods, that we'll learn in our next session.